Now allow me to introduce our keynote speaker, a dear friend that I have had the privilege to work with and for in the past. Trase Travers is a successful business leader, a subject matter expert in the critical field of mission assurance, a field that will gain a higher degree of significance in our industry, embraces technical solutions with ever-increasing complexity and criticality. Trase recently led Artcos LLC, an integration of 6 aerospace and defense businesses into a full lifecycle support enterprise. Prior to this, Trase led several other businesses as CEO and has led the mission assurance support contracts for NASA and the United States Air Force and other elements of space community. It's my pleasure to introduce Trase Travers. Thank you.
Am I on? I'm going to assume
you are on. We can
good
see
deal.
you and we can hear you. Go ahead.
All right. Well, Bodotaji. I've been practicing that, on and off here today. But thank you very much. I'm Trase Travers. I'm honored to be here with the Portuguese Air Summit today and to present to you what I think is something that's near and dear to my heart, which is that of mission assurance and how it affects our overall ability to create sustainable and safe and effective solutions as we move forward. Thank you very much, Carlos, for that introduction. I wish I could be there in person. Instead, I'm talking to you today from Pensacola, Florida. Not my home, nor is it Portugal, but not a bad place to be either. As you may know, Pensacola is the home of the U.S. Navy Blue Angels and is a center of aviation excellence in itself. So fun to be here, working toward helping them recover from their Hurricane Sally impacts over the last 4 weeks. And as Carlos pointed out, aviation in the future will embrace an ever-increasing technological complexity and systems interdependence. We're integrating greater degrees of technology, lower technology maturation levels as we achieve to ferret out some of the margins and achieve greater performance and ability in our overall systems. Throughout my career, I've been fortunate to have supported the space industry from several different perspectives and have taken away some lessons learned relative to developing and producing and operating highly complex systems that bear great complexity. And I hope today to have a few words that will help us in terms of the context of how that applies to the Portuguese and European and American partnership in aviation. Like in space, like aeronautics, we're always on the cutting edge and seeking to reduce those margins to achieve the next level of mission performance. That, of course, implements or develops a greater degree of risk, and that needs to be matched with a higher degree of discipline and rigor in order to achieve our overall goals. I don't see slides, so I won't talk directly to the slides here, Carlos, but so I just wanted to provide a little perspective on my career. I actually started out at the Cape Canaveral Air Force Station, the Eastern Range, launching rockets and actually blowing up wayward rockets. And I still sit here and scratch my head and wonder how I'm not still doing that. As a young man coming out of college, getting to blow up wayward rockets for a living, I just still wonder why I'm not still there. That was the coolest job ever coming out of college. But then it gave me a lot of great insight into the highly hazardous activities that we were doing, which provided a baseline for my technical expertise or experience as we set the foundations of mission assurance. And I tell you, especially this set within my overall fabric, watching the failed consequences of a launch and picking up the pieces off the beach really gives you that firsthand perspective of what can go wrong and why it is we do the mission assurance elements that we do. I also got a chance to work on a different perspective as well. I spent some time in the Earth science missions and spacecraft of Goddard Space Flight Center, and as well moved over and got to support and see the intricacies of Missile Defense Agency and its highly interdependent system solution sets there. Also got to work with the Kennedy Space Center, kind of the heart-thumping human space launch mission activities there, and have had the opportunity and the honor to support every U.S. launch range across a civilian, defense, and commercial space mission. And really, through this experience, I've seen many ways to achieve a similar goal within mission assurance. There's more than one way to skin a cat, and each of these approaches needs to be tailored to its specific application, but they all share common threads and core pillars of overall capability. Mission assurance is defined in a lot of different ways. NASA has a particular way that they define it. MDA, all the various agencies out there have defined it in unique ways. But each one, I think, implements and integrates sub-elements that are very common. And they all really involve an engineering-based discipline understanding and a systematic method and procedures to ensure repeatable performance. This is really anymore coupled within a risk framework, a means of quantifying and qualifying the probability of occurrence with the consequences of an event. It's really become a thorough baseline for all of our engineering and programmatics, and it's really stemmed out of these mission assurance disciplines over the years. These pillars produce a process-based discipline and rigor needed for the team, as well as guides the application of resources in a manner that is consistent with where your risk and where your opportunities really lie. In doing this, we all arrive at a system capability of producing repeatable and predictable outcomes, and that's where we really need to be. In terms of sustainability, mission assurance affords very specific advantages. One, it reduces the waste of rework and decreases the energy associated with having to approach rework, errors, failures, and what have you. Having an optimized design that stems from a mission assurance discipline is got its great advantages. Doing it right the first time is incredible. Doing it wrong just once can have devastating, lingering, and far-reaching impacts to not only our organizations but to the industry as a whole. Additionally, the life expectancy of a system should be optimized and enhanced through the application of balanced mission assurance practices. We get a better understanding of the environments that the system is going to be operating in. We have a tendency to think outside of those environments to bring in margins that are credible and result in system lifing that far exceeds that otherwise would be typically developed. We also realize this value proposition of mission assurance as the system complexity increases, especially as we implement cutting-edge technologies and interdependencies of our system become much more highly engaged within our overall system. Keeping up with these interdependencies and interface requirements requires more of a discipline and more of a rigorous approach to ensure these risks are not lost in the mix. The value proposition is also true when the consequences of system failure are so great, such as human risk, environmental impact, civilian infrastructure disruption. Just one disaster in any of these veins could have ripple effects that impact far beyond the local system or operation. The goal of overall mission assurance is to produce reliable, safe systems that are free of defects and in a manner that reduces the amount of waste in the system lifecycle analysis. Yes, there are additional costs to field reliability engineers, quality assurance and control specialists, system safety professionals, but the overall impact on the system will far exceed the cost over time. Management will need to weigh both tangible costs and intangible costs in determining resource optimization and achieving world-class organization. Additionally, lifecycle cost advantages of a well-designed system need to be considered when we're looking at overall system performance and cost. Importantly, the rigors of mission assurance identify trends, including negative ones, and provides for leading-edge metrics that allow us to revector our attention and our resources along the way, such that we can avoid mishaps and and other negative elements that can occur. Lessons learned are very important to help build our organizational corporate memory. And the use of the risk management framework helps us focus our resources, priority, and attention of the mission assurance organization toward these elements and activities that present the highest return on investment. For example, a system involving complex manufacturing methods may need more quality assurances and supply chain oversight from quality professionals. And additionally, others that are in their formalization really need to apply more of a rigor of reliability engineering. We'll talk about that here coming up. And overall, the risk management has become a vital underpinning of the effective assurance approach in a common framework of everything. As industry, government, and academia progress the art of the possible, new challenges and opportunities present themselves in terms of mission assurance methods. A couple of these things that I've seen in my career have been things like the synchronizing our mission assurance activities with the systems engineering lifecycle. This is something we really pressed hard on in the early 2000s as part of NASA headquarters and Goddard effort. Good example would be that reliability engineering and applying those tools and efforts early in the system formalization trade studies, such that it really produces the value of ferreting out the true mission requirements and optimizing the design to meet them. Other elements that have really been revolutionary in our industry lately have been things like model-based systems engineering and the ability to optimize the design within the cyber domain long before metal is bent. When mission assurance teams are proficient in model-based tools and integrated with the design teams, highly innovative methods can be explored in meeting the demanding mission assurance requirements. The next level of instantiation of the cyber family is digital engineering. Creating a digital twin of a specific production item that matures from concept to design, optimization through production and engineering modification, all the way to operations and sustainment activities provides a really unique opportunity for mission assurance professionals to apply data analytics and really seek to understand the trends and derive knowledge from all this available information that typically would not be available to us within a classical system engineering and data management approach. And another important element anymore is really cyber resiliency. It's become a table stake in everything that we're doing. Cyber vulnerabilities are a significant threat and risk to every system that we develop and must be at the forefront of integrating from a mission assurance and engineering production standpoint. And this really needs to be considered across the entire life cycle. Some of the things I've seen recently in the U.S. Air Force, even down at the sustainment centers, where we're plugging in test equipment and finding out that we have massive vulnerabilities that we need to, that we have since closed the gap on. But really needs to be looked at from a complete standpoint of all systems that touch the interdependencies and employ firmware or software or have an IP risk. Like many disciplines, mission assurance has pitfalls as well. First, our design engineering team typically thinks in what I'll call the success phase. They're always contemplating how to achieve the mission and less about what can go wrong. Really, mission assurance professionals need to put their hat on backwards. They need to think about things from the failure space and a mentality to find out and root out what can go wrong and make sure that that gets into the overall system requirements and is ferreted out through system design and production. There's also the dilemma that we run into in mission assurance. We do our job really well, nothing blows up. And then the boss starts looking around and saying, well, why am I spending so much money on this? I'm doing a great job otherwise. So it's always a challenge to keep management focused on the balance of the entire system and maintaining their world-class organization. There's a whole subject area of that I could go into, but it's more of an art than a science. Additionally, our mission assurance teams need to maintain independence. Independence from management, independence from engineering at times, and they can't be compromised by the pressures of time, cost, and performance. However, we all know that those are the three most important things in any system development, and the mission assurance team cannot be on their own island. They need to be integrated, independent but integrated, and it's a very hard balance to achieve But it's something that we need to strive for day to day in everything that we do as an integrated team. And there are times where it's challenging, where the government agencies utilize the same OEMs and vendors, and we see that there's a tribal approach to mission assurance representation and within the independent plants, and we need to do a better job of providing similar oversight and cross-utilizing resources that are available across various agencies and government elements out there. I think that's been improving over the years. Organizations such as CQSDI are doing a great job of identifying opportunities in that domain. At the end of the day, the high-performing mission assurance team needs to find that perfect balance between independence and team integration. The entire team needs to be of the mindset that mission assurance is not solely the responsibility of the quality, safety, reliability teams. It is the providence of the entire team: production, engineering, operations, mission assurance. They need to work in harmony. They need to have an incentive alignment to make that happen. And it needs to be done within a culture of meritocracy for it to be very effective. And importantly, culture starts at the top. Senior leadership needs to take a very active role in setting priorities, demonstrating behaviors, and applying resources consistent with the goals and needs that have been expressed and developed by the organization. And although the value of mission assurance is difficult to measure in fully quantitative terms at times, it is a hallmark of a high-performing organization, a world-class organization. And I think, and I hope that it's something that we all can achieve in our individual and our team endeavors. So thank you for your time, and please have a great session.
Thank you so much, Trace. Appreciate it very much. Just let me add that we typically, as a keynote speaker, bring someone that is a bit outside the box, that broadens the views of what we typically have been working on. And Trace, you did a magnificent job. I want to thank you very much. And hopefully we can look forward to having you here in person next year in Portugal if things go back to normal and we have an in-person event next year. So thanks again for the presentation, and looking forward to seeing you.
Thank you. Thank you all.